Hello everyone. In this video we're going to talk about inequalities, and this video is going to have two different parts. The first part is talking about solving inequalities. The second part will talk about actually graphing inequalities when they are in two variables, meaning an inequality that actually has an x and y variable rather than just having a single variable like just x or just y. We don't typically spend a lot of time on solving inequalities in algebra, and the reason for that is it's basically the same process as just solving an equation. There are just certain rules that you have to remember. Specifically, when you're solving an equation, you just have an equal sign. And when you're solving, and I'll write equation there. But when you're solving an inequality, you have four different signs that can show up. So the four signs that can show up are this sign, this sign, this sign, this sign, and that fifth one that we don't really use a whole lot would be this. If we are writing our math in the correct form, we write our variable first, so like x for example, and each one of these would be read as follows. X is less than, the point goes towards the x, that means x is less than, it opens towards whatever you're saying is larger. So x is less than, say, 5. And if I change this symbol, the order stays the same. Your wording just changes a little bit. So like if I make it this, that means x is less than 5 or it's equal to 5 as well. And if we change this sign around, that would mean x is greater than 5, and this would mean x is greater than or equal to 5. And essentially, before, when you're dealing with an equation, when you have this equal sign, you're saying that whatever you're solving for can only take on one value. So x is 2, x equals 2, or x equals 3. When you have an inequality like this, you're just saying that my x value, or whatever variable, could be something other than x, whatever I'm solving for, in this case, this value of x, it can take on multiple values. So if it can take on multiple values, I don't want to use an equal sign because that implies there's only one value it can have. And then last but not least, technically this is also an inequality symbol. That means does not equal. So you would use that if you were trying to say like your variable x, for example, does not equal 7. So generally speaking, the problems that will show up with inequalities in algebra can look something like this. You'll be told to solve, and you might have something like this. 2y is less than or equal to x plus 10. And the process for solving this would depend on what you're told to solve for. If you're told to solve for x, then you would subtract 10 from both sides just like you normally would, and you would wind up with 2y minus 10 less than or equal to x. But notice up here I told you that you had to read left to right. So this is technically written backwards, and so we can flip this around, but make sure that the orientation of the symbol stays the same with respect to x. So what I mean by that is if our symbol's opening towards x right here, if we flip this around to actually read it the proper way, then we want that symbol to flip with it. So we would say x, flip that symbol because it has to come with x, and then 2y minus 10 would go on this side. Notice here that it's still opening towards x, so this says the same thing that it said up there. But here's the difference. If I read this up here, this says 2y minus 10 is less than or equal to x. If I read it down here, this says x is greater than or equal to 2y minus 10. They mean the same thing, but they're read differently. And notice how we've actually used two different symbols, but we're conveying the same meaning. And that is what confuses students the most with inequalities. It's just the fact that you have to read from left to right, and what the symbol actually means is based off whatever is to the left of it. The only exception to this rule, or the only exception I should say that makes solving inequalities different than solving equations, is when we introduce negative numbers. If I say solve for, this time I'll just say solve for x, okay? So there's no mystery. We're solving for x. And let's say I have negative 2x is greater than or equal to 2. If this was given to you as an equation, that should be a super quick problem because you should recognize, all right, this is a negative 2 times x there's no other operation going on. I'm being told to solve for x, and all I've got to do is divide both sides by -2, and I'm left with a -1 over here. Here's the catch. If we divide by a negative number, or multiply both sides by a negative number, it actually causes this sign to flip. So instead of the sign remaining opening towards this x, it actually flips. So I'm not going to go into extreme detail on why that happens, but basically, before this said -2 times whatever x is greater than or equal to 2. Now this says that my x would have to be less than or equal to -1 for that up there to be true.